lesson note from today. You are starting probability. There's a test on this. That's it. No assignment. Your assignment now is homework. That's still due Friday midnight, but we need to move on. So, can you please today, you're not going to do any timeline exercises, but can you download the probability booklet that's attached to DayMap? It's Year 10 Maths Probability. What am I going to teach today? I'm going to revise sample space because that's assumed knowledge now. I don't know what you did for probability. I was asking student over here whether he knew what sample space was. So there was a vague idea about what sample space was, but I need to make sure that you're on top of that. There's no practice exercises today, just the notes. If you finish getting those, apply your feedback to the final version of the measurement DI. And then if you finish that as well, when I see it uploaded, you're going to have free time. Okay? So there's a new booklet attached to DayMap. Now we get into the notes. So let's see if you know any of this stuff. You're supposed to have covered probability in Year 9, but it's not your teacher's fault. Your teacher's always going to focus on the heavy hitting stuff like algebra. Probability is a topic that always sort of gets pushed to the back. But because of your timeline and you've been advanced, we've got plenty of time to do probability here. So I'm going to go over assumed knowledge for Year 10 because I don't like to assume things. The main assumed knowledge is the idea of sample space and the different ways we can draw a sample space. So, student that I was talking to here because it was early, a sample space is the full set of possible outcomes. He would only know that because you were taught that at some point. What is the sample space of rolling a 6-sided dice? Possible full set of possible outcomes. What would the outcomes of rolling a 6-sided dice be?
Numbers 1 through 6.
Good. What would the sample space of flipping a coin be? Heads or tails? The edge if you're really lucky. Okay? That's what a sample space is. So the idea of a sample space is really quite simple, but you need to be on top of the ways of drawing a sample space, which includes lists, which includes grids, tree diagrams, and Venn diagrams. So please note the following. I'll give you time for your cheat sheet if these are unfamiliar. If you know all of this already, that's awesome. Well done. I won't write your certificate because if you know it all already, then don't write them. Just show me in your test, okay? So please think of this lesson as a review and a reminder, and the notes cover what you need to know going into Year 10 probability. So the first kind of sample space we'll go over is the idea of a list. A list indicates all possible outcomes in set notation. So what does that mean? You put all the outcomes within curly brackets and you separate all the outcomes with commas. I've drawn a diagram of a spinner here. Look, it's 3D. There's a shadow and everything. What are the possible outcomes of that spinner? Yep. Purple. Next. Next. And according to what you've just learned now, formally, a list needs to be the results separated with commas. But what's missing from this? Brackets. I need to separate it. I need to surround them with curly brackets because that's formally something you do if you did probability in higher levels. So a couple of minutes, please, to copy down to here. That is what a list is. So has anyone seen that terminology about what a list is? Putting stuff in curly brackets? No? Is that new? Old? Something borrowed, something blue? No? Have you seen this before? Like the idea of putting the results within a curly set of brackets? No. Good. Okay. That's new. All right, that is the first way of representing sample space. The second is a grid or an array. Grids or arrays are an efficient way of representing the sample space of an experiment, but that involves two operations for each outcome. Each axis in the grid represents options for each operation in the experiment. Each point on the grid represents an outcome. So we'll show how that works for this example where you are flipping a coin and rolling a 6-sided dice. Which of these axes do you think would fit the 6-sided dice? The bottom one or the vertical one? The bottom one. Why?
Because it's 6 points.
Good. So the axes represents the possible options for that aspect of the experiment. With a dice, you roll a 1, 2, a 3, 4, 5, or a 6. What's the other aspect of the experiment? Now that we've dealt with a dice, what's the other aspect? Coin? What are the options for flipping a coin? Good. So we've done the axes. What do the dots represent? What does this dot that I have just drawn represent happening in that experiment? I flipped a and I rolled a. Good. What does this one represent? Flipped a, rolled a. Good. So how many dots should there be here? I've only done 2. More than 6. Because there's 2 options for each one of the number. There should be 12, okay? So hopefully you can see, even though I could do a list, I could do one of these for that experiment. But that list would look ridiculous, okay? That list would be heads 1, heads 2, heads 3. That list's going to go on forever, right? That's going to be quite a long list. It's going to have, 12 different options to that, and you might stuff it up. Whereas the grid is like a visual representation of what could happen there. You were getting it as I was describing it. I could put a circle around this and go, what happened to the experiment for that dot? I flipped a heads and I rolled a 5. Right? So visually is always, a picture's worth 1,000 words. Okay? What is a tree diagram? Oh, sorry, give you some time to copy down to there, please. That grid and how it's used. We'll add an example. This dot represents flipping a tail, rolling 5. Time to copy that. So hopefully you'll see today, there's no maths involved today, you're just getting this information down. You're expected to understand how these work for the maths that we'll do on Wednesday. What's funny? You right? All right, let's have a look at the tree diagrams. I'll keep that there. What is a tree diagram? It's used when an experiment involves more than 2 operations or steps to represent all outcomes. So if I wanted to use a tree diagram to represent the sample space of flipping a coin 3 times. A grid is not in 3 dimensions, so I can't represent that. I need a tree diagram now because there's more things to happen here. So how am I going to use a tree diagram to represent this? We go flip 1, flip 2, flip 3. This is where the tree starts. On the first flip, what are my options? Flipping a coin. What are the options when you flip a coin? Heads or tails. But then, now that I've flipped a heads and I flip it again, what are the options for flip 2 when I flip a coin? Still heads or tails. But now that I've flipped a coin and I got a head, and I also got a head the second time, what are the options when I flip the coin a third time? See how it looks like a tree now? So this tails, I could get a head or tail after flipping that. This tail, I could get heads or tails. This head, heads or tails. This tails, heads or tails. So the sample space This is a representation of all the possible results. Every set of branches is a possible result. What's this? What is the result that I have circled here? Head, head, head. Someone else. What is the result that I have circled here for the 3 flips? Good. Do you agree that the list, if I was to draw this with the list, would there be a chance of missing something? There'd be a high chance of missing a possible combo. If you draw it, because you know that there's 2 options per flip, it's kind of hard to stuff it up, okay? So that's a tree diagram. Then the lastly is time to copy that, sorry. Okay. Get that tree diagram now. Do you all know what a Venn diagram is? Have you seen what we're talking about there? Describe to me in words, as if you're playing, I don't know, Pictionary or something, what I would draw for a Venn diagram.
Two or more circles.
2 circles overlapping. They don't have to overlap. Is there something on the outside of those circles? Okay, we'll fix that. You have an idea what a Venn diagram is, but when we do it, for me, we do it strict. So Venn diagrams are a kind of graph that are used to represent sets of numbers. The most common type of Venn diagram consists of, this is what you didn't tell me, there's always should be a rectangle that represents the universal set of numbers. This encloses the numbers within the circles, okay? The circles inside the rectangle representing sets within the universal set. These circles are labelled alphabetically A, B, and C. Can you get this description of what a Venn diagram is with the specifics of the universal set for now? And then we'll try filling in these 3. And then we're done for today. You can use the rest of the time to apply your feedback. I didn't get anyone's feedback in at 3:15 because I had to drive to school at 4 a.m. to see if the Dame Up was working on the school network. It wasn't. It was just down. You don't have to write anything. I would like you to. This is stuff that can go on your cheat sheet. Okay, let's practice filling in these Venn diagrams. These Venn diagrams is always for the 6-sided dice. What is my set of results for a 6-sided dice? 1, 2, 3, 4, 5, 6. But this, question A, it's telling me A has 1 and 2 in it, and B has 1, 3, and 4 in it. So, let's label. U is the universal set. Let's label this as A. Let's label this as B. Any takers? Is there anything going to go in the overlap between? What's in both sets? 1. So we've done that. Is there anything that's only in set A? 2. What's only in set B? 3 and 4. Don't forget, there's the universal set. My whole set of data includes 1, 2, 3, 4, 5, and 6. So where would 5 and 6 go? Would they go in any of the circles? They just go in the rectangle, yeah. I don't care where you position the numbers, they just have to go in the right place. Next one, B. Are there any numbers that will go into the overlap between the circles? Which one? 3 and 5. 3. 5. What only goes in A? 1. Is there anything that goes by itself in B? No. What am I missing from the universal set? 2 and 4 and 6. Looking at example C, why are these circles separated? There's no overlap. There's no common to the middle sets. So this is actually kind of easier. When I first started this stuff, I thought it was harder, but it's kind of easier. What would go into the left circle? 2, 4, 6. What would go in the right circle? 3, 5. Is there anything in the universal set that's missing from that diagram? 1. Time to copy.